So good morning, my viewers and also my students. So we are going to solve this question, which says that the figure below is an arc of a circle with the points A, B, and C. On the arc, determine the coordinates of the center of the circle. So I want you to be aware that this is an arc of a circle, and therefore the key thing we are going to find is the coordinates of the center of the circle. If we extend this arc, it will form a circle which will have a center at that particular point. So we need to find the center with the coordinate of the center. So we are going to begin with the first approach, whereby we know about the equation of a circle. So this is a circle with the center. Let us call the center O, which is AB. Those are the coordinates of the center O, AB. And on the circumference, we have the points A, B, C. So following the approach whereby we have the general equation of a circle, which is given by x minus a into bracket squared plus y minus b into bracket squared is equal to r squared. We follow this approach and we arrive at the values of a and b, then we get the center of this particular circle. Now, what we need here to know is that from O to A, that is the radius, which is also the same from O to B and also from O to C. This is equal to the radius of the circle. So we can be able to use the general equation of the circle to form equation for OA, OB, and OC, and then we find the value of unknown. So in our case, the points on the circumference will be of the form X, Y, and the center of the circle, the coordinates are AB. So if we are going to take point O and A, let us take the 2 points and we form what? The equation of the circle. So we substitute those values into this general equation for O. So x is minus 3. So we have minus 3 minus A into bracket squared plus y is 5 minus b, that's what we have, squared will be equal to r squared. We call this the first equation. Then we can also take taking point O, and we can take point O and also we take point B. We take the 2 points. So then we substitute the values. O is AB, B is 0, 2. We substitute also into this particular equation. So we are going to get x is 0. So 0 minus a squared, then plus we have y is 2. So 2 minus b squared is equals to r squared. We call this the second equation. And also we take point O and C, take point O and C, also we form an equation. So we have minus 3, substitute into the general equation, minus 3 minus A squared, then plus y is minus 1 minus B squared is equal to R squared. This is the third equation. So we compare the three equations. We can take pairs of equation. We can take equation 1, and equation 3. The reason why I've taken it so is simply because we have this value corresponding to this, and to some point it's gonna eliminate one another. So we equate the two. So let us equate 2. So we have minus 3 minus A to bracket squared plus 5 minus B squared is equal to minus 3 minus A to bracket squared plus minus 1 minus B to bracket squared. So in this case here, so we have this shown, and this one will eliminate each other, and therefore we remain with 5 minus B into bracket squared and the other one. So if we expand this using quadratic identity, we get 25 minus 10B plus B squared, and the other one will be, this will be 1 plus 2B plus B squared, and therefore the same case, B and B squared will cancel, and therefore we remain with, so 24 minus 1, that will be mean 25, minus 1, that will be 24, will be equal to 2B plus 10B, that is 12B, and this implies that B is equal to 2. Also, if we take the other one, so now we already have the value of B, so we can consider equation 2. So we have 0 minus A, that will be minus A squared, plus 2 minus B is already 2, 2 minus 2 squared will be equal to R squared. We can consider any other equation, the left hand side. So I can actually take equation 1. So we have minus 3 minus A squared plus 5 minus B, and B is 2, so that will be 5 minus 2, that is 3, 3 squared, that will be 9. Right, so here we have this will be, this was actually positive, so when we square it, that is A squared plus 0 will be equal to, if we expand this, it will be 9, then minus, so this will be plus 6A plus A squared, then plus 9. So in our case here, again A squared and A squared will cancel out, and therefore we end up having, so this value, so we have 9 plus 9, so 0 we have 18 plus 6a. So this ends up being minus 6a is equal to 18, and therefore a is equal to minus 3. And therefore the center of the circle, which is AB, the value of A is minus 3, and the value of B is 2. And that is the center of this circle. That is the first approach. Now, we can move to the second approach, and I'm going to explain it so that you find which one will be easier for you. So we have the second approach. This is still the question. So we need to find the center, coordinate of the center, OAB. Fine. Now, one thing we need to note that is we can use matter of, since this is an arc A, B, C, and we have extended this circle. Remember, if I join AC, let me join AC, and then I bisect this chord. Remember, this now AC is a chord. It always passes through the center. It always passes through the center of the circle. So this will be the midpoint of AC. So we can find the slope of AC, and then we find its midpoint, and we find the equation of the perpendicular bisector of AC. So let us find the midpoint of AC. Midpoint of AC. So to get the midpoint, we had the x coordinate divided by 2, and also to get the y coordinate, we had the y coordinate divided by 2. So this will be minus 3 plus minus 3 all over 2, and the y coordinates, that will be 5 plus minus 1 divided by 2. So we end up getting, this is minus 6 over 2, that is minus 3, and the other one is 4 over 2, which is 2. Now, that is the midpoint of line segment AC. To get the slope of AC, it is change in y over change in x. So change in y is 5 plus minus 1, which is 4, divided by minus 3 plus minus 3, which is 0. So this is undefined. That means this is a vertical line. And since a vertical line whose gradient is undefined, then slope of perpendicular bisector of AC is horizontal line. It's an horizontal line, and therefore its equation will be equal to the line y is equal to 2. Remember, this is the midpoint of the line segment AC. So that is the equation. The other case, we also need to form another equation. We form a simultaneous equation. We solve for the values of we get the midpoint. Now, the other case is, now let us take point BC. Let me draw this line segment BC. For BC, we require again, we get the midpoint of this chord BC, and if we bisect it to get the midpoint, the line always passes through the center. The line always passes through the center. So we need to get the midpoint of BC, line segment BC, then we get the equation of the perpendicular bisector of BC. And that will be, so midpoint of BC will be, let us add the AX coordinates, we divide by 2, 0 plus minus 3 divided by 2, and the other one is 2 plus minus 1 divided by 2. So we end up getting, this is minus 3 over 2, and here we have a half. So that is the midpoint of BC. Then we need to get the slope of line segment BC, and the slope will be, that is change in y, so that is 2 minus minus 1, so plus 1 all over, then 0 minus minus 3, so 0 plus 3. So we end up getting 1. If that is the case, now the slope of the perpendicular bisector of line segment BC will be, remember, a line multiplied by its perpendicular bisector, the product is always minus 1, and therefore the slope of perpendicular bisector of BC is minus 1. So now we can take this point, the perpendicular bisector, and to form an equation. We already have this, so we require to get the equation. So we take maybe another point xy to be on line with this, and therefore we have this and another point x, y. So we get the equation. So change in y, by minus a half all over x minus minus, so plus 3 over 2 will be equal to minus 1. This implies that y minus a half will be equal to minus x minus 3 over 2. Therefore y is equal to minus 1. Therefore we have minus 3 over 2 plus a half, that will be minus 1. So this is another equation. So we already have two equations, y is equal to 2 and y is equal to minus x minus 1. So we substitute y is equal to 2 into y is equal to minus x minus 1. So here y is 2 is equal to minus x minus 1. So minus x will be equal to 3, and therefore x is what? Minus 3. And y is 2. Therefore, the coordinates, now remember we have solved the simultaneous equation. So the point of intersection, that is the solution. So the value of x, which is minus 3, and the value of y, which is 2. Therefore a is minus 3, b is, so the center will be minus 3 and 2. I hope you have followed clearly and you now get the concept, and that's how to do this particular question. I've taken time so that you can follow which way to go about it. So thank you so much. Let us meet in our next video. God bless you.